Spring Boot is a very famous Java-based framework and is being widely used these days. If you have some programming background and would like to have quick start with Docker, this video will be an excellent source of information. Hi, my name is Huram Hanif and I will explain you A to Z for creating Spring Boot application and running it using Docker. Welcome to the next video of Easy Sample Application series using Docker and Kubernetes. Please note in this video we will perform basic steps to create an application which is ready for Kubernetes. However, we will not deploy the same application to Kubernetes in this particular video. In this video, I will explain how to create a custom build application and run using MySQL database along with Docker. A quick recap for our previous video about MySQL and PHPMyAdmin. In that video, we created MySQL database and we also installed PHPMyAdmin, and then we saw some data using the browser. In addition, we also discussed Docker networks and different types. I will highly recommend you to watch that video using the link below in description. Before watching this video, as this video is a continuation of the previous video. In this application, we will create a Spring Boot application with REST API and endpoints will be exposed. There are certain tools required to successfully run that on local desktop. As discussed previously, we will need a Docker desktop. Docker desktop can be downloaded from docker.com/products/docker desktop. Then you need obviously Java 8, and Java 8 can be downloaded from oracle.com. The last tool we'll need in this particular video will be Apache Maven, which can be downloaded from maven.apache.org. Once you have downloaded and installed those tools, you need to do some verification to verify if your Java is installed properly. You need to execute something like Java version, and as you can see it's 1.8, and you also need to check if Maven is installed properly. You can see that Maven is also installed properly, so which is good. And to check, the last tool we'll check now is the Docker. Here you can see that Docker is up and running. And while on this screen, we can also see that this is the Easy service which is already running on port 8080. So this, I would like to show you this before we go into weeds and create the application and try to configure using Docker and Docker-compose. So because right now it's running, what I will do is I will open a browser window and see if we can get data. So I opened a window and I'll type something localhost and 8080 and /dishes. Again, this really doesn't matter. You can name it and I will show you where to change it or how you can define those endpoints. But the main thing is that this endpoint is up and running and we are getting data back, and this data is in JSON format. So this is the state of our application and that's our target state. What we will do now is we will stop this service and delete it altogether. There are obviously different ways to do it, but we are using Docker desktop to do this. Okay, done. So now we will go back and start our basic steps to create the application and run it using Docker. Start.spring.io is the website which is called Spring Initializer. Now as we know, Spring Boot is actually an extension of Spring Framework, which was being used heavily for a long time. And over the time, the complexity of setting up Spring Framework was immense. So Spring Boot provide us a quick way to create the Spring framework-based application, and then we can choose what kind of dependency we need. To do so, we need to provide a group name. So for example, in my case, it's com.nano.s. You can choose any name you like. You can leave it like this. And artifact is, let's say, easy eat. This is our flagship sample application. And then we can say easy eat Spring Boot services or something like that. You packaging is jar, and then you need to select the version. I'm keeping it to Java 8, and then we can add the dependencies. In under the dependencies, you can choose, for example, this one, dev tools, then Spring Framework, which is used for the RESTful API, and then we don't need. You can use Jersey. If you need JXRS APIs, I'll add it for now. Reactive Web, Spring Sessions, nothing there. Spring Security, we are skipping the security for now to keep it simple. And Spring Data JPA and Spring Web Services, Apache, Groovy. Can keep going. MySQL driver, we'll need that one too. And I think that's basically it. But don't worry, if you forget anything to add, I will show you how to do it retrospectively using the POM file. But for now, what we will do is to generate this file. So once we'll click that generate button, there will be a pop-up window to show it somewhere. For now, what I will do is I will create a temp folder and put it over there. Once done, showing folder. Okay, now we have that one. We can extract all. Yes, please. And now we can see that one. Okay, so some words on the structure of this application. There will be a source folder, there will be a POM file, and under this source folder, there will be resources folder where application.property exists. And under the Java com nano and then easy it. This is the now package structure as we defined in the initializer web page. So we can open this one and we can see that this is the Spring Boot application. So let's open the POM file. Okay, so this is the POM file generated. We can see that this is the group ID. This is the artifact name. This is the description for the application, and this is the parent. You need it for the Spring Boot application. And then we can see there is JPA, Jersey, Web, DevTools, MySQL connector, and starter test, and everything is there from there. Okay, so this is a screenshot for our database table dish, which we already discussed in previous video. So based on that one, now we have a new entity class in our model package. So we can see common nano is it is the same what we created. So I created a new model package and created the dish annotated with the entity. And the structure of our table is we have an ID column, we have a name column, we have price, and we have details. I kept it integer. We can debate on that. Should we change it to decimal to store decimal values or not? But for the easiness, let's keep it integer. And then there are setter and getter functions, and then there is an equal function, and then we have the hash code and toString function. Then we have this repository which has JPA repository and the ID related to that. So very simple thing, nothing rocket science over there. And then we have the dish controller. We have the controller package now. And under that one, I have created the dish controller, which has the REST controller annotation over there. This is the repository, how we have defined it over here. This will be the injection for the repository. And then we have the get mapping defined over here. And this is the place where we always saw that probably an E was missing. We can fix it if we like, because we are already there. Okay, so, right. Okay, so we fix that one. And yeah, basically that's it. So this is the get mapping, which will be get invoked, and it will, based on the repository, it will return the list of dish. Yeah, so basically that's it. So let's go back, build this one, and run it in Docker shortly. Okay, so this is application.properties file, and this server.port is 8080. Then we have the driver class for MySQL, which is com.mysql cj.jdbc.driver. Then we have the URL, and if you can recall, Docker-compose file, you will remember that we have named it MySQL db2, and the port is the same 3306, and it is the database. Now the password and username, we left it root for the simplicity. Then we have the dialect, and rest of the information is over here. Now let's go back to the command line and execute mvn clean package. Okay, so build is successful. Once we can see directory dir, and we can see a target folder. We can go into the target and directory, and we should be able to see our jar file generated over there, which is easy, it's service jar. Great. So now we'll move on to next steps. So far, we have gone through the introduction. We have a quick recap for MySQL phpMyAdmin, and we have created a Spring Boot application. And right now we are going to focus on Docker file for Spring Boot application. Make sure you are following the same case. If it's uppercase, you need to create in the uppercase, expose 8080. This is the port which will get exposed. Add target easy eat service.jar. This is target is the folder which we just saw, and this Docker file will reside in the root folder, where the target folder is also there. So you will say add target, and then you can basically just copy paste this one. This will make sure that this jar file is added to the Docker image, and then entry point is this one, and this is basically a sequence of parameters minus jar, and then comma easy eat service dot jar. So that this command will get executed within the Docker file. It is very similar to this. If we will have to go back and say Java minus jar target and something like easy it service dot jar. So now this Spring application is starting in my local, but in the Docker file, what we just did, this one will get executed within the Docker container, and it will start an instance of this easy it service within the Docker container. Now we'll need to save it. So we'll say save as, and then this is our root folder as explained earlier. So you will need to say Docker file and save. So just save the Docker file over there, and basically that's it, what needs to be done within the Docker file. Now I would like to show you this error message, and this is the when I try to run the application within my local host, we got this unknown host exception MySQL DB2, and this is because our local machine don't know what this MySQL DB2 is. However, when we'll create the Docker Compose file, we will go through this one, and I already explained that in my previous video, that why MySQL DB2 is available within the network created by the Docker. So once you're so as we know from the previous video that this MySQL DB2 will be available within the Docker network. So there will be no issue running this one over there. Okay, so that brings us to our last part of this video, which is the Docker Compose file. And now we will go ahead and modify the Docker Compose file. This is the same file which we created in the previous video. So let's have a look. Okay, so let's modify the Docker Compose file. This is the same file we used in previous video when working with MySQL and PHPMyAdmin. So we already went through these services. In this Docker Compose file, there are two services defined. One is DB and the other one is PHPMyAdmin, which depends on the DB service. Now, in this particular video, we will create a new service. Service 3 SpringBoot application easy it service. Then we need to define the image, which is easy it service container name is easy it service app, build context colon docker file ports or 8080 is the exposed one on the machine, and 8080 this one is the internal to the container. Start always depends on DB. Environment is So those are the environment specific data source URL, username, and password. So this contains this container name, which is defined over here, MySQL, and root is the default username password we chose earlier. And basically that's it. Now we will save it and give it a try. Okay, before we execute Docker command up, we need to make sure that we build the application. So we'll execute the command. So we'll say mvn clean package again, so that we have, this is to make ensure that the endpoint names which we changed get reflected into the jar file. And we'll see directory target and target. Okay, so we can see that easy heat service jar is there. Now we'll say docker, or maybe clear it, docker compose up, and it's now building and fetching the images which are not available. Now it's creating db2, and okay, we can see that it's now running on port 8080. So let's open a browser window and test it. So if we say http localhost and dishes, we should get an error, and the reason is because we have renamed the endpoints, which confirms that this is the change one. And now because we use the correct endpoint names, so we can see that the JSON data is being sent back to the client. Okay, and we can also test that using Postman. So you can see in Postman we still have the old endpoint. So if we'll send it, we'll get this 404 not found, and once we'll correct it, we can see that is 200. Okay, and we can see that the data is flowing back to the Postman. So yes, now the last point, what we can also do to double check, we'll go back into the Docker desktop application, and we can see easy service. We see MySQL DB2 running on port 3306, and we can see easy service running on 8080, and PHP MyAdmin is running 8082. We are not going to test PHP MyAdmin because we did that in last video. So that concludes our video about Spring Boot application and how to run that using Docker with MySQL database. I hope you have enjoyed it. If you have any questions or comments, please feel free to leave it under the comment section. And also, if you like the video, please feel free to like the video as well. Thanks and have a good day.